Naga.
Okay, fine. Okay, so welcome you all to TIECONN 7th webinar. So today, as you know, we have a very interesting topic today. So hello everyone. We are super excited to have you here today. So before we jump into the webinar, so this is like yes, menu card before the technical buffet begins. So we have today a technical webinar that is more powerful than your coffee. So what is TIECONN? It's not a robot, it's not a spaceship, but a big family of engineers, students, and experts from around the world. So as many of you know that what is our mission and mission statement. So our mission and mission is like a Google map, which is very clear view what we have. Our goal is to help young professionals to learn and grow in their field. So we organize great events so engineers don't just build buildings, but also they build careers. So these are our committee members. These are our real superheroes. So they don't wear caps, but they are sure that how to power up TIECONN. Here is our leadership team. They are like the motherboard of TIECONN, connecting everything, solving problems, and yes, even staying cool when system overheat. So these are our country chairs and our secretary and vice secretary. So this is the country chairs from different countries we have here. So they represent TIECONN in their countries, the true leaders with an international passport of passion. And here is our country vice chair. They are the backup generator for us. They make sure everything runs even when the main power is down. So this is our technical advisory teams. So these experts keep our content strong and sharp, like a good engineer's pencil. Our youth and student division. This team is full of young energy and future leaders. They are the battery pack of TIECONN, always charged up. So these are the pillars of TIECONN, the event organizers. So these folks plan every event like a wedding, but with more engineers and less dancing. Our media team. This team handles all the communication, posters. They make TIECONN look like very cool online. So finally, meet our session leader, Mr. Asif Akhtar. So he has more than 30 years of experience in the electrical installation and designing works. So here is to take us a journey of learning. So get your pens, notes, and maybe even popcorn ready for the webinars. So let's begin our 7th webinar, electrical load calculation for the high-rise building. Yes, Mr. Asif, you can start now. You can share your screen and you can start. Thank you.
Okay, Naga, I am sharing my screen.
Yeah, please share. Yeah.
Is it clear to everyone?
Yes, it's clear. Yeah. Please make the full screen, huh? Please.
Yes. This is okay, Naga?
Yeah,
Is
it's
it
clear.
clear to everyone? Okay.
Anyone has any issue? I think it's okay
Anyone
from
has
my side.
any issue?
So is it okay? Is it
Yeah,
okay? Is
it's
it
okay.
okay?
No,
Please,
no, no.
please.
It's okay.
Yeah.
Okay.
Okay, please start. Yeah. Okay. Thank you.
Hello everyone. Hope you are also fine. Bismillahirrahmanirrahim. Hello everyone. Hope you are also fine. So today my topic is high-rise building electrical load calculation. My name is Asif Akhtar, and I am working in EFE Life Assurance Limited for the last 8 years as a chief engineer, senior manager post. Being a professional electrical engineer, I have 21 year experience in different industries: textile, power plant, high-rise building projects, banking, insurance, and information and communication technology, K-electric distribution system, and electrical data center infrastructure project planning, designing, implementation, and operation and maintenance experience in my throughout uh, 21 years career. I did my graduation from NAD University of Engineering and Technology in the year 2002, BE Electrical. Now, let's start the presentation. Is my voice is clear? Uh, Hello?
Yeah, it's clear. Okay.
Yeah. It's clear.
Yeah, it's
Okay,
audible.
okay. So basically, this is a kind of case study project I've selected so that everyone can learn new skills and technology according to the new market trends. So the topic of my presentation is designing an electrical load calculation for our 10th floor building. So it is okay?
Yeah. Okay, sir.
Okay. So let's start. So is what is high-rise building? As per NFPA, NFPA means National Fire Protection Association. A high-rise building is defined as uh, occupied floor above 75 feet, yani 22.86 meter above the lowest level of fire department vehicle access. So this is or NFPA classification is written below any low-rise building below 15 feet, uh, uh, 12.19 meter, mid-rise building 40 to 75 feet, and high-rise building above 70 feet. So this is a standard of NFPA kind of classification. So then I go to next slide. Why why proper load calculation is required for the electricity connection in high-rise building projects. So basically, it is very important for proper load calculation before obtaining an electricity connection for high-rise building project for several reasons, ensuring adequate supply, prevent undersizing. If the electrical load is underestimated, the supply may be inadequate, leading to frequent power outages, voltage loss, and potential damage to the equipment. If and or if you select the kind of preventing oversizing. Oversizing estimate that the load can result in unnecessary expenses due to which your cost is be increasing due to higher connection fees and installation costs for oversized transformers and cables. So hope this point is clear to everyone why proper load calculation is required for making the smooth operation of the building. If anyone have any question? Hello.
No, you can continue, I think. Yeah. If any
No,
question,
sir.
they
No,
will
sir.
Main
answer.
Continue.
Yeah.
main
Tell me,
main
continue.
main main reason for proper load calculation is prevent undersizing and prevent oversizing. Then number second point is safety. An accurate load calculation help in designing the electrical system to handle the expected load and then preventing overloads that can cause overheating, fires, and other safety hazards. So main is for safety is also is necessary for proper load calculation and proper sizing of protection devices means you have to select the circuit breaker, fuses, breakers uh, correctly to interrupt fault currents and protect against electrical faults. Hope this point is also cleared. Then number third is cost efficiency. Proper load calculation, optimizing initial cost can optimize the initial cost by avoiding over specification of electrical component and infrastructure. So reduce operational cost, efficiency, design system, reduce energy losses and operational costs as well as maintenance expense over time. This is the third main important point of this in this calculation. Next, planning for future expansion. So you have to design a system in such a way that there is a stability of the system in your system. And the proper load calculation take into account potential future expansion, ensuring that the electrical system can accommodate additional loads without major modifications. So you have to do this uh, in your, keep your mind, keep your mind. Hello, my voice is clear.
Yeah, it's clear. Yeah. Fine.
Acha, number five point
Yes.
is system performance, ensuring voltage stability. Main accurate load calculation help in maintaining stable voltage levels throughout the electrical system, preventing voltage drop that can affect equipment equipment performance. So you have to sure in your electrical system that the proper voltage is being coming in your facility or high-rise building or hotels or in anyone else. So main thing is voltage stability is very necessary. Then importance of load calculation. Why load calculation is important? I am sharing my experience in one of my project in our building. Recently, I am working in EFU Life high-rise building where I am looking operation and maintenance of the whole building there, in which I am looking transformers, generators, lifts, UPSs, data centers, VRF system, floor killers, and lightning system, each and everything. So I am sharing my one of my experience in here so that everyone can aware and and learn new things. A notable experience for one of my project involved a vendor recommending a 4 into 40 kV UPS for our lifts. We have 4 lifts in our building, which prove cost prohibitive. A detailed load calculation, I proposed 2 into 40 kVA UPS, which have operated seamlessly for 16 years, yielding substantial cost savings. So this underscores the value of accurate load calculation in optimizing UPS sizing, reducing distances, and ensuring reliable performance in critical infrastructure like data center and lift. So you have to do load calculation, accurate load calculation. So in this way, you can save lots of money of your organizations. Not knowing load calculation can lead to overspending on unnecessary capacity. Number two, undersizing causing power issues. And number three, inefficient system performance. If you don't do the load calculation correctly, your system will not work smoothly. So, Alhamdulillah, for the last 8 years, uh, our electrical system is working fine in our high-rise building. So, let's move on. Hope all the points have been cleared. Hello, it's my voice is audible.
Yes, your voice is audible.
Yes, yes, yes. But
Okay.
PPT not
Now,
moving.
typically not moving.
No,
No,
PPTs
no,
are
no,
moving.
no.
You have to refresh your page. We are currently on the contents.
Okay, okay.
Acha, okay.
Okay.
Now the contents of this presentation is divided into 5 parts. Number one is total connected load. Number two is transformer sizing. Number three is circuit breaker sizing. Number four is electrical conversion formulas, which is very important to do this calculation in your projects. Number five is single line diagram. Do you know about the single line diagram? Single line diagram is also known as one line diagram. Most people use single line diagram or most people use one line diagram. So next step is five key steps for efficient and reliable infrastructure. So what is total connected load? Total connected load calculation objective determine the total electrical load that the system must support. Number one is most important point. You have to determine the total electrical load that the system must support. Number two, transformer sizing. Objective, select an appropriate size transformer to handle the total connected load. So you have to select the right transformer, otherwise your building will not, otherwise your building or your apartment or your hotels will not operate effectively. Number three, circuit breaker sizing. Circuit breaker sizing is very important on the transformer side. Objective, determine the appropriate size of the circuit breaker on the transformer side. You have to select the circuit breakers according to the transformer rating. Number four, circuit breaker sizing for the connected load. Objective, choose circuit breaker that protect the connected load while ensuring efficient and safe operation. And number five, the last is single line diagram. This is very important. You have to read and understand how to read and implement the single line diagram in your system, or develop a clear and concise representation of the electrical system layout. Introduction. So let's move on. If everything is clear. Hello.
Yes.
Hello.
Yes, everything. Yes, everything is clear.
Rana, Naga, how many people I have joined right now? I think
33
23.
is there.
So everyone is, my voice is clear.
Yeah. If anything issue, we will inform. No issue. Yeah. You can
Okay,
proceed. Yeah.
okay, let's
Yeah.
move. Okay,
Because
let's
our
move
people are
on.
eagerly watching the presentation, so there are no comments from
People,
them. Yeah.
people are very silent. Uh,
No,
We
because
should
you
ask
have
the
a lot of
question
lots of
in
comments.
at the
You
end
have
of
a
the
lot of
session,
lots of
right?
notes. They are reading and they are
so
listening. Yeah.
if you have any question, you can interrupt me. So that um, I can clear your points. If you have any question, okay. So
Okay.
introduction.
Thank you.
Introduction. So this document provides a comprehensive exploration of the electrical load and circuit breaker sizing for a ground plus 10 residential building. I have selected this building includes 2 BHK, 3 BHK and 4 BHK flats. What is BHK? BHK means B for bedroom, H for hall and K for kitchen. So this building includes 2 BHK, 3 BHK and 4 BHK flats. ठीक है, each with specific connected load. Each with a specific connected load. The focus of this analysis is on the individual apartment loads, 2 BHK, 3 BHK, and 4 BHK, and common loads. Common loads including lighting, pumps, and lifts. The understanding the electrical load and selecting an appropriate size transformer are critical steps in designing a reliable and efficient electrical system. This document provides detailed calculation for the load distribution across different panels within a building, taking into account common loads and floor specific load and applying a demand factor. The transformer selection process is also discussed considering the load requirement and conversion factor. Conversion factor is both important. You have to look into very seriously. And number third is load distribution across panel, common load and floor loads. We will discuss in this webinar. The electrical load distribution is categorized into 4 panels, such servicing a specific set of loads within the building. The common load includes elements such as lift, pumps, and lighting. We have divided this uh, uh, load, common load, into lift, pumps, and lighting, while individual floor loads are based on the type and size of the residential units. Panel breakdown. We have used in this presentation we will use 4 panels: panel 1, panel 2, panel 3, and panel 4. Panel 1 we Panel 1 is common load, ground floor plus first floor load. Panel 2, second, third, and fourth floor loads, and panel 3, fifth, sixth, and seventh floor loads. Panel 4, 8, 9, and 10 floor loads. ठीक है? This this is a high-rise building, or in this building, I have divided this building into 4 panels: panel 1, panel 2, panel 3, and panel 4, and each panel is comprising of second, third, and floor. The basic requirement in this video in this webinar, I have used 2 types of calculation. One is single phase and other is 3 phase, so that everyone can use hello, my voice is clear. Hello.
Yes, your
Yes.
voice is clear.
Yeah,
Yes.
it's
Yeah.
very clear.
In this in supply for which will be used in 2 BHK apartments, and 3-phase supply which will be used in 3 BHK apartments. Energy meter provided by electrical companies. Here any 2 BHK apartment, so electrical companies in Middle East will provide you a 5 kilowatt energy meter. And if you have 3 BHK apartment, so electrical company provided you a 7.5 kilowatt meter. It is basically for your load. And for 4 BKH apartment, the electricity company will provide you a 10 kilowatt energy meter. It's okay?
Right. It means that you cannot exceed 5 kilowatt for 2 BHK. You cannot exceed the load above 5
Yes,
kilowatt.
you are right. Yes, you are right. In 2 BHK, the electrical company will provide you a 5 kilowatt energy meter. This is the standard set by the electrical company. सही है? And for 3 BHK, you will provide 7.5 meter energy meter. This is 5 kilowatt energy meter. This is 7.54 energy meter. And you will not exceed the load above these above this kilowatt. अच्छा,
Sir, if is there any sir, if is there any made rooms are and 1 BHK sir attached for servant rooms?
One
So there is a
BHK.
common one.
Yes,
If you have 2 BHK flat, sir, are you horrible?
In this video, there is no 1 BHK apartment. You can use 1 BHK apartment.
Okay, sir. If is there 2
No, sir.
BHK, so that 2 BHK flat having a one servant room or maid room. So the
2
same load
BHK
will be
apartment.
taken.
No,
Yeah,
actually,
it depend
what they're
upon.
asking, Mr. Asif, they're asking if we have a maid room, attached maid room in the 2 bedroom apartment. So that time, still this 5 kilowatt is applicable, or we can increase or decrease something.
Yes, sir. Yes, sir. Exactly.
Yeah, basically, electrical company will provide you a 2 BKH apartment for 5 kilowatt load. Either you use 1 kilowatt or you use 2 kilowatt. It depends upon your needs. If you have 2 AC, if you have 3 AC, so then load will automatically will increase. But you have the electrical company will provide you a full 5 kilowatt loads. Hope this point has been cleared.
Yeah, that means even 5 kilowatt, even we have the maid room, correct? Even we have the maid room,
Yes.
2 bedroom means.
Yes. It depend upon your needs. If you have 4 AC and you will operate 4 AC, then your load will be increased, and it depends upon your needs. But
Sir,
electricity
you
company.
have said that now, sir, for 2 BHK it is to 5 kilowatts is standard now, sir. If the if we are
This is a standard.
yes,
Yeah, this is a standard.
if it is standard in BHK, if it is standard, if we
Uh,
are using more than the like you are saying that ACs are ACs and
if
what
you are
are the
using more than the 5 kilowatt, your energy meter will be burned out because you will exceed the load, and an electrical company will give you a kind of a penalty why you have extending the load.
okay.
Okay.
Mr. Asif, sorry. Mr. Asif, is this connected load or demand load? This 5 kilowatt.
This is kind of a connected load, overall connected load. Demand load is different from the connected load.
Yeah. Just this is
Okay.
connected load. Okay.
Yeah. Okay. It's okay. Let's move on. Hello.
Yes,
Let's
yes.
move on.
Yes. Please move on. I think we have spent enough time on that.
Basically, this is a scenario I created for ground plus 10 residential apartment building, in which we have number of lifts is 3, which have a rating 10 HP. Let's suppose, सही है, 2 BHK apartment on each floor is 4, 3 BHK apartment on each floor is 3. ठीक है, 4 BHK apartment on each floor is 3. Let's suppose or number of bore pumps I have selected is 2, which have a rating 5 HP, and number of water pump uh, uh, is 4, which have a 5 HP. Number of floors in this residential building is ground plus 10 floor building. Common lighting loads is 20 kilowatt. Parking, lobby, and staircase area. Total connected load. Total connected load is sum of connected load from apartments plus sum of common loads. So you have to calculate the total connected load is sum of connected load from the apartment plus sum of common loads. Common loads which I have told you that that is common load is lighting load is or number of water pumps and number of bore pumps. This calculation includes the connected load of individual apartment considering the specific details for 2 BHK, 3 BHK, 4 BHK flat and the load associated with the common areas like lifts, bore pumps, water pumps and lighting. So there are two types of loads involved in this calculation. One is for apartment and one is for common loads. Ensure that all values are in the same unit, usually in kilovolts, kilovolt amperes or watts for accuracy. The result will give you the total electrical load that the building needs to be designed for. Now this is a very important calculation. No one can tell you about it. Total common load. Calculate the total common load in kilowatts. For 3 lifts with a total of 10 HP, so the formula is total power for lift is equal to 3 lifts multiplied by 10 HP. So is equal to 30 HP. So convert HP to kilowatt. You know that 1 HP is 746 watts. So if you convert watt into kilowatt, then we will divide 746 into 1000. So we will get the figure 0.746 watt. This is the figure you are showing here, 0.746. So we will multiply 30 HP into 0.746 kilowatt is equal to 22.3 kilowatt. So total power for 3 lifts is 22.38 kilowatt. Is this clear? Is this calculation clear? If anyone has question, please ask me, or otherwise I will go on. I hope
Clear, sir.
I will explain. I hope you will know it. So for 2 bore pumps with a total of 5 HP. So total power for bore pump is 2 pumps. We have 2 pumps multiplied by rating 5 HP is equal to 10 HP. So convert HP into kilowatt. Same formula will be used, which we use above. So 10 HP multiplied by 0.746 kilowatt is equal to 7.46 kilowatt. सही है? And now for 4 water pumps with a total of 5 HP. So total power for 40 water pump is equal to 4 pumps multiplied by 5 HP is equal to 20 HP. Now convert HP to kilowatt. As I told you that 1 HP is 746 watts and you have to convert watts into kilowatt. Then you have to divide 746 into 1000 divided by 1000 is equal to 0.746. So and you have know that lighting load is 20 kilowatt. Now you have all the common load calculations have been done. Now
I have a
total
question.
common load. Yeah.
How did we calculate the lighting load? If it's at a high-rise building, and how we will calculate the lighting load for the common areas, whether it is calculated on a per square foot or the footsteps of the people living there. Is there any specific formula for that?
Yeah, both it depends upon the building size. So I have just for your understanding I have add 20 kilowatt. So 20 kilowatt will be include kind of parking area, lobby area, staircase area. If you add all these things, so it will be approximately 10 kilowatt to 15 kilowatt. It depends upon the building size. It will be increase or decrease more.
Or we
Okay.
have to manually count all the lights that we install there.
Yes. You can also manually count the lights also.
Like if
Okay.
10 10 watt light, there are hundreds of lights installed, then we can estimate the total kilowatt load.
Yes. You can also do this also.
Is on the other hand, you have the limitations of load 5 kilowatt of 2 HBK. If we don't have the limitations, then how can we calculate the total connected load? We have to count or sum all the kilowatts we have installed or watts in a particular flat or building.
I will show you in this presentation. Let's see. It is showing total common loads is equal to lifts plus bore pump plus water pump plus lightning loads. We have to add all these loads. Hello? Understand?
Yes, sir.
Hello? So we have to add all these
Yes,
loads.
sir.
Lifts plus bore pumps plus water pump plus lightning load. So total common load is 65.76 kilowatt. So the total common load is approximately 60.576 or 66 kilowatts. Okay? So now total load for 2 BHK flat on each floor. Now in previous in slide I have told you that for 2 BHK flats we have the electricity meter we have provided is 5 kilowatt. So 4 flats. Now the total load for 2 BHK flat on each floor is 4. So number of flats on each floor is 4. So then we will multiply by 4 flats into 5 kilowatt is equal to 20 kilowatt. Okay. Now total load for 3 BHK flat on each floor is 3 BHK 3 flats multiplied by 7.5 kilowatt is equal to 22.5 kilowatts. Number third is total load for 4 BHK flats is 3. So in each floor there are 10 flats. Okay. 4 flats for 5 kilowatt, 3 flats for 7.5 kilowatt, and 3 flats for 10 kilowatts. So now the total flat load on each floor is total load for 2 BHK, total load for 3 BHK plus total load for BHK flat is equal to 20 kilowatt plus this. Now total floor load is 72.5 kilowatt. So this is the calculation of all the loads of 2 BHK, 3 BHK, and 4 BHK apartments. Now total flat load is total flat load in each floor multiplied by number of floors. So now number of floors we have is 10. So now the total loads of the flat is 725 kilowatts. 725 kilowatts for 100 flats. So in this calculation, we have concluded that if we have 100 flats, so our load is 725 kilowatt approximately. Now add these two values to get the overall total floor load. Now we have total load is equal to total common load. Now we have also add the total common load in this calculation also for main transformer sizing. Total common load flat load. Now total load is 7.5 is common load plus 725 kilowatts is equal to total load. Now if we add these two, now we get 790.76 kilowatt. So the total load considering both common load flat load is approximately 790.6 kilowatt. Now most important is potential demand in India and Pakistan. In residential area, the India and Pakistan, the demand factor we will use for 50 to 70, and in Gulf country 90%, and in commercial industry we will use 50 to 70%, and Gulf country 90% approximately, depend upon the transportation demand. And for industry in India and Pakistan, we will use potential demand in 90%, and in Gulf country it is 125%. Now let's calculate the transformer sizing. The demand factor is used to account for the fact that not all the connected load operate simultaneously at full capacity. This is the most important point. If the demand factor is 60%, it means that you expect only 60% of the total connected load to be in use at any given time. So the demand factor is expressed as a percentage. So how we calculate the demand factor? Recommended. Let's suppose we will use in this calculation the demand factor is 70%. Now let's calculate the demand load using the demand factor. So what is the formula of demand factor? Demand load is equal to total load multiplied by demand factor. We will assume the demand factor is 70%. So total our calculation is 790.76 multiplied by 70%. So the demand load is 553.53 kilowatt. So now if your potential demand is 553 kilowatt, it means that you need to select a transformer size that can handle at least this amount of load. So typically transformers are available in standard sizes, and you would select a size that is equal to or greater than your potential demand. Now, is this screen clear? Transformer sizing. Hello.
Clear, sir. Clear, sir.
No, sir. No, sir.
Yes, no, sir.
Somewhat blur, sir.
Is it clear? No, I hope it is clear now.
Why
Network
can't
issue,
we
I think.
use transformer 790 kilowatt on the safer
Sir.
side?
I will explain a bit. Is it clear? The screen is clear?
Clear, but it is
Please
somewhat
explain the difference.
Transformer sizing. That page is waiting for transformer sizing. We have two type of transformer, and one is dry type transformer and other is oil field transformer. It depends upon your budgets, and both have advantages and disadvantages as well. So mainly in our high-rise building, we are using the dry type transformer. The main function of dry type transformer is the fire risk is very low, and maintenance cost is very low, and installation or it is the cooling medium of the dry type transformer is air, whereas you know that oil type transformer, the cooling medium is oil, and the cost of the oil type transformer is lower side. So we can use both the transformer depend upon the budgets. Transformer standard size are 63 kVA, 80 kVA, 100 kVA, 120 kVA. These are the standard size of the transformer used in the industries, Pakistan, Gulf, America, USA. So these are the standard size of the transformer. Now, now in my previous calculation, we have to convert the kilowatt into a kVA. As you know that if your power factor is equal to kilowatt upon kVA, then so now we in my previous calculation we have 553 kilowatt. Then we divide the 553 kilowatt into 0.8. So once we divide, we will get the calculation 691.9 kVA transformer. So as you know that there is no transformer available in this rating. So we will select the transformer above this. So selecting 800 kVA transformer. As you know that there is no 630 kVA, then 630 kVA, then the transformer is for higher is 100 kVA, 800 kVA. So we will select the 800 kVA transformer for this high-rise building. So selecting a 800 kVA transformer for a load of 691 kVA is conservative and safe choice. This is a safe choice. Choosing a transformer with higher capacity than the actual load provides a safety margin and ensure that the transformer operate comfortably within its rated capacity. This approach is common in engineering practice to account for potential future load growth and variation in loads, and to prevent the transformer from running close to its maximum capacity, which can impact efficiency and reliability. Hope this point has been cleared now.
Yes, it has been clear.
Now, this is a very important calculation for three-phase supply. If we want to convert kVA to ampere, we will multiply by 1.4. So your question is where is 1.4 coming? So I will explain into you on the next slide. If you remember in your metric or interclass, if you read for three phase power formula, as anyone knows what is the formula of three phase power and single phase power. Can anyone tell me the formula of three phase power?
For three phase, we have under root 3 into V phase into I phase.
Very good. For three phase. And for single phase power, what is the formula of power?
Is simple V phase into I phase into power factor.
Very good. Yeah. Very good. Your name?
My name is Muhammad Ali Raza.
Muhammad Idris. Yeah. Very good. Yeah, Idris. Acha.
Muhammad Ali Raza. Muhammad Ali.
Muhammad Ali Raza.
Muhammad Ali.
Yeah.
Muhammad Ali Raza bhai. Good. Yeah. Muhammad Ali Raza. Good. Acha. In this calculation, we will use we will use these type of formula here for three phase kV to ampere. The conversion factor is 1.4 and HP to ampere 1.5, kilowatt to ampere 1.9. For single phase kV to ampere, the conversion factor is 6, HP to ampere 6, kilowatt to ampere 8. Acha, for example, let's use the conversion factor to convert the transformer kVA rating to ampere. अच्छा अब हमें जो है ना जो ट्रांसफार्मर की रेटिंग है उसको एम्पियर के अंदर कन्वर्ट करना है. तो गिविंग द ट्रांसफार्मर साइज इज 800 kVA फॉर थ्री फेज सप्लाई, ट्रांसफार्मर फुल लोड करंट multiplied by conversion factor. For three phase supply, transformer full load current is equal to 800 kVA multiplied by 1.4. The 1.4 is coming from where? kVA to ampere. 1.4 kVA. We have a transformer 800 kVA. 800 kVA multiplied by 1.4. I will show you where 1.4 is coming. Okay, in my next slide. So once we multiply by 800 into 1.4, then we will give the load current is 1.20 ampere. So this is the total load of the transformer which can handle the load. Now we will select the ACB for this transformer. Now we know that there is no ACB for 1120 side, then we will use the ACB for 125 ampere. So what is ACB? Can anyone tell me what is the mean of ACB and where we will
It's
use?
air circuit breaker.
And what is MCCB?
And MCCB is miniature molded case circuit breaker. I think.
No, miniature no. Miniature is MCB, miniature circuit breaker, MCB, and MCCB is molded case circuit breaker.
Case circuit breaker, yes.
Okay, sir. Air circuit breaker. Air circuit breaker is an electrical protection device used for overloads, short circuits, and earth fall and overcurrent protection. Which it is almost used in LT panels, in substation and main distribution boards. What type of breaker we will use in ST system?
We
Can
will use
anyone know?
VCBs.
VCB,
Vacuum
yes,
circuit
very
breakers.
good. Very good. Very vacuum circuit breaker. It is used for higher current capacity. So based on the provided conversion factor for kV to ampere for three phase supply, the full load current for 80 kV transformer is 1120 for three phase supply. 800 kV multiplied by 1.4. Transformer full load is 1120. So suitable circuit breaker is 1250 ampere, which will handle all your loads in high rise building. This is the conversion formula which I have discussed to you.
Here I have a question regarding selecting ACB, whether we select a 3-pole ACB or a 4-pole ACB.
Basically, you have my advice is to use 4-pole ACB so that neutral can be in case of any issue, neutral will be disconnected, or you can use three-pole ACB also. But my suggestion is used to use 4-pole ACB for safety point of view. Okay.
Okay.
Which I am talking about, conversion formula, 3-phase supply. So if you do this calculation, you will get the figure. 1 kilowatt is 1.9 ampere, 1 kVA is 1.4 ampere. This is the formula which I am using. 1 kVA is power divided by under root 3 multiplied by voltage. This is the formula, or multiplied by cos theta. You will use the power factor in this formula, and the rating of the is 0.85. If you use all these calculations, you will get 1.44 ampere. Okay. And this is a single phase conversion. We use power is equal to VI formula. Circuit breaker sizing for main panels and flats. So we have used in this webinar in MCB, MCCBB, and ACB breakers. So there are 3 types of breakers are used in this kind of distributions. Now, certainly, let's perform separate calculation for the circuit breaker sizing for 2 BHK, 3 BHK, and 4 BHK, and the common load. Let's break down the load calculation for each panel based on the floor distribution provided. Now, panel number 1. Panel 1 number 1, we have calculated common load 65.76 kilowatt. For 2 BHK on floor 1, we know that we have on floor in 2 BHK we have four flats and each have 5 kilowatt. So we will multiply 4 into 5, so 20 kilowatt. Then for 3 BHK, 3 multiplied 7, 22.5 kilowatt. For 4 BHK, it is 30 kilowatt, and so it's going on. Now the total load for panel 1 is 65.76 kilowatt plus 72.5 kilowatt is equal to 138.26 kilowatt. This is the load of the panel 1. In the same way, we have do the calculation second floor, third floor, fourth floor. Now we will add all these. So now the panel 2 load is we will add all these loads. So it is 217.5 kilowatt. In the same way, the panel number 3, 5th floor, 6th floor, 7th floor, we will add all these. Now we will get 175 kilowatt. And for panel 4, 8th floor, 9th floor, and 10th floor load, which is same as you know. So the total load for panel 4 is 217.5 kilowatt. Now suddenly, if the demand factor is 70%, we can apply this factor to the total load calculation for each panel. Now actual maximum demand for panel 1 is 138.26 multiplied by demand factor. We will get the figure 96.782 kilowatt. In this way, we will do all the calculation of panel 1, panel 2, panel 3, and panel 4. Hope you will understand. Now, suddenly, if you want to use the conversion factor directly with the transformer KVA to calculate the to the current, you use the formula in table 3.1 ampere. So in panel 1, ampere for panel 1 is 96.782 multiplied by 1.92. We will convert kilowatt into ampere. Once we once we once we once we calculate into ampere, we will multiply into 1.9. 1.9, where this come from? This come from the calculation which I have explained in my previous slide. Now, now for panel 1, we will use 250 ampere MCCB, and for panel 2 and 3 and 4, we will use uh, 289 ampere. So we will use the circuit breaker 400 ampere MCCB. So this is a cable sizing chart used in in different industries and according to your manufacturer. In Pakistan, there are Pakistan cable used and fast cable used in India as per your requirement. So this is a chart which will be taken you from there also. So now what is the last my topic is single line diagram.
It's the cable chart for copper cable, right?
Yes, copper cable. I will show you I will share you the Excel sheet which I have prepared. So I will share in on LinkedIn, so you can download as well.
Okay, sure. Thanks.
Okay, you will get each and everything is clear in this sheet as well. I will share. Don't worry. Okay, what is single line diagram? Single diagram, also known as SID or one line diagram, is a simplified representation of an electrical system. Symbols and lines are used to represent the nodes and connection in the system, and electrical characteristics may be included as well. What is single line diagram used for? As a single line diagram is used to distribution of power through a facility. The diagram should be kept accurate and updated as equipment in the facility is added, removed, or changed. So this is most important. You have to edit, remove, or change in your single line diagram as per your needs. The benefit of using a single line diagram: become familiar with your power distribution system layout and design, simplifying planning, troubleshooting, and increasing the efficiency of maintenance activities. Number third, maintaining safe operation to protect personnel. This is the single line diagram which of the system. So it is not clear, but I will show you the in my I will share the connect the in my next slide. So I think it is clear in this single line diagram we have 11 kVA system. Then we have a 800 kVA direct type transformer which convert 11 kVA into LT system. This is a step down transformer which convert 11 kVA into three phase. So this is the diagram of this of whole infrastructure. Now my presentation has been completed. Thank you.
Yes, if anyone has any question, please ask your questions now. Yeah.
Or if you have any question, if you don't understand
Yes.
anything, you can ask me on my WhatsApp and my email address as well. I will try my best to in
I
detail.
think the distribution panels calculation should be explained in details, whether how to select the short circuit rating and how we do the short circuit study to select our breakers short circuit like 16, 18, or 36, because it's very really important to protect the electrical equipment during that time.
Yeah, basically this is the kind of this calculation which you are talking about is a separate. So inshallah I will cover in my next webinar. Don't worry.
Hi, Mr. Asif. Yeah, the session was excellent. for
Thank
my
you, sir.
sake
Thank
of
you, sir.
understanding,
Yes,
let's say you are saying about oversizing, undersizing for the transformer, whatever it is. So usually we are doing this at the designing stage for the selection of for the permit and all. So let's
yes, yes,
say as a mechanical engineer, I'm giving a input for the mechanical item like AC and fan, whatever it is related to AC.
yes, yes.
Maybe during the construction stage, uh, people understood that the load given is undersized or oversized. So
Mm.
based on my value, you designed your transformer. Later on, you found that there is a discrepancy. So how do you address this case scenario? That is the first question. And the same, let's say if a customer want to upgrade load or upgrade the condition after during the construction or after the construction, maybe for the future, how do you gonna address these two?
Basically, sir, what is your name, sir?
My name is Hansil.
And sir, if your load calculation is not accurate, so you will not want if you will not design the system. So you have to gather all the data correctly. So that's why otherwise
I
you will
think
not you will suffer.
I think, yeah, Mr. Yeah, that's the point. Maybe I think for the electrical, they need load details, maybe during
Yeah,
the
yes.
concept stage. Okay, so
Concept,
that
yes, you
stage,
are right.
yeah, that
Mm.
stage, maybe the mechanical team won't give you the exact calculation. Maybe they give you
Yes,
the oversized.
oversight.
Maybe let's
Yes,
say,
yes.
yeah, maybe you need only 50 kilowatt for the AC, but I give you
Mm,
80 kilowatt. So
mm,
you are going to have a system with oversized transformer. So
mm.
are you going to recalculate during the construction stage, or you gonna purchase the material based on the
Yeah,
concept?
we have we have to calculate the load calculation and transformer sizing in construction phase. We have to look these in very deeply in construction phase. Otherwise, your building will not operate and will face issues if you don't
Uh,
proper size the
can
calculation
if
in
I
construction.
add to your answer, like he's just like our fellow is saying, that mechanical load is not going to be like that. Okay, you are saying that we are designating 60 kilowatt or 80 kilowatt. The
Mhm.
mechanical load is
Yes.
designed whether it's doing you are going for the plant room or central chiller, or you are going for the VRF system, or whether you are going for the air handling units. And the capacity of the
Mm,
handling units, the tonnage will calculate the kilowatt hours, the associated pumps, condenser pumps, primary pumps will also contribute to the load. And if you are going for the chiller, then it will also contribute to the connected load. So there is a detailed
oh,
study of the mechanical load before going for the transformer sizing.
yes, you are right. You have to calculate each and everything because right now I am working in high-rise building in which all the AHUs, FCUs, and main chillers are installed. First, we have to calculate each and everything. Then we will select the transformers. Otherwise, our building will not operate if we don't do the calculation correctly. Alhamdulillah, for the 8 years, our building is operate accurately because
Mr. Asif, I
uh,
think 80% of the building load is HVAC load.
yeah,
Yeah,
yes, you are right. Yes,
but
you are right.
sorry.
80% of the load is building.
So sorry to add one more point. But what if I give you the undersized, okay, and you are getting the approval from the Deva anything related to the authority. They are giving you
Mhm.
the approval for the, let's say, 100 kVA as a transformer. And
Yes.
later on, do we have any option to upgrade the transformer during the construction stage?
No, if your transformer is selected and in the end your load will increase, then you will request the क्या नाम है, Deva or any authority to upgrade
Mm-hmm.
the
Okay.
क्या नाम है load in
Okay.
future, or you have
Okay.
to select the क्या नाम है, or you have to add more transformer if you want to add the क्या
Ah.
नाम है load.
Mm-hmm. Okay.
Otherwise,
Okay.
your building will not operate accurately.
Yeah, that is possible. So we can add one more transformer if it is required. Like if my question was second one was if customer want to
Uh,
expand the system or for the future provision or something. In that case, we can add the one more
Yes.
transformer, right? Yeah. Okay. Great.
Yeah.
Thank you.
Yes.
Yeah.
Yes. 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 You are right. Yes. You are right.
Okay. Thank you. Thank you very much.
Thank you. Naga, please share the question and answers which I have prepared.
Yeah, anyone has any question? I will go with the quiz section. Yes.
तो आसिफ भाई नेक्स्ट जो है आपके जो जितने भी वेबिनार मैं फर्स्ट अटेंड करूं टाइकॉन के, इट्स रियली इंफॉर्मेटिव, एक्सचेंज ऑफ इंफॉर्मेशन अच्छी है। तो ये आपके मैंने व्हाट्सएप ग्रुप को भी मैंने रिक्वेस्ट कर दी फॉर ज्वाइनिंग के लिए। तो ये आपका जो है सारा उसी के ये बाकी जो आपको डाटा शेयर करेंगे, जो आप एक्सेल का या आपकी पीपीटीज हैं, वो आप व्हाट्सएप ग्रुप में शेयर करेंगे कि लिंक्डइन ग्रुप में शेयर करेंगे?
जैसा जैसा आप कहो यार, मैं लिंक्डइन पे भी शेयर कर सकता हूँ, मैं ईमेल पे भी शेयर कर सकता हूँ, जो आपको आसानी हो
आई
मैं
थिंक
उसमें
व्हाट्सएप
कर
ग्रुप
दूंगा।
में जो है उसमें शेयर करते हैं ताकि सारे मेंबर्स उधर से ही वो उससे जो है ना फायदा उठा सके।
अच्छा, ओके ओके, आई विल शेयर ऑन दी व्हाट्सएप ग्रुप, इट्स
और
ओके।
वो शॉर्ट सर्किट एनालिसिस स्टडी वो आपने लास्ट में एक वेबिनार रखना उस पर।
हाँ इंशाल्लाह ताला, आई विल शेयर इट आल्सो, डोंट वरी यार। If you have any question, or if any point is not clear, note my WhatsApp number which is showing in this slide. So I will try my best to answer your question, inshallah. Don't worry, yaar.
ओके, जज़ाक।
Yeah, fine. So now we'll go to the quiz section. I'll share you the QR code, and so the same time I'll share the link also in the chat box. So those who cannot scan this QR code, because some people are watching in the mobile itself, they can use the link also. So please give your answer in 1 minute. Yeah, hello. Yeah.
Hello.
Yeah.
Yes,
Now
sir,
I'll share the
listening, sir.
questions. Yeah, I'll share the questions in the chat box. And also you can see my screen, the QR code now soon. First I'll put the questions in the chat box so you can start the writing the answer. And here is the QR code. Please write your full name. Please write your full name correctly and also your mail ID correctly so we can contact you tomorrow morning.
Naga,
Yes, yes. Yeah.
how much more time will be required?
Yeah, 1 minute. Yeah. Should wait for
Sure.
1 more minute or so. Yeah. Okay, so we got 18 responses so far. Friends now. Yeah,
Sir, please approve the request for joining WhatsApp group.
yes, I will approve. Yeah, sure. Okay, so finally, Second, we are in the final stage of the webinar. So thank you all for your active presentation in the webinar, and you asked lots of questions in the webinars and after the webinars also. It was very interesting that. So as I told earlier also, the success of the webinar depends on how people are engaging in the webinar and how you people are frequently asking the questions. So I think we have done it very well. And I think Mr. Asif has done it very, very good today. It was really an insightful webinar for all of us, and we have learned something very new. Mr. Asif, you answered all the questions in a really very well explained manner. I hope all people are satisfied with his answer. And still, if you
Thank you,
have any
Naga.
other questions, yes, you can contact him in the WhatsApp group. He's available with our webinar, our TIECONN group. So you can post your comments in the TIECONN group. So we are there to answer all your questions 24/7. So we have a very big technical team. It's a growing community, so we request all you to join in the WhatsApp group as well as our LinkedIn group. So because we are sharing all the question and answers in our LinkedIn group only, and also we are discussing lots of upcoming webinars and topics in the LinkedIn WhatsApp group. So I request you to join for the WhatsApp as well as the LinkedIn group. So thank you for all the participants. And Mr. Asif, you want to say something?
Thank you all. Thank you all of you and Naga and the Con Elite panel for giving me an opportunity to present the presentations. So thank you all of you. Hope you will learn. Hope you will learn and enjoy the webinar. Thank you all of you.